Hello students, today's question is given that the Laplace transform of the function below over a single period 0 less than t less than 2 is 1 upon s square into 1 minus e raised to minus s whole square. Then the Laplace transformation of the periodic function over the range 0 to infinity is. So this is the function we have given, and what is the Laplace transformation of this function is the option A is 1 upon s into 1 minus e raised to minus s whole square, 1 upon s into 1 minus e raised to minus 2s whole square, then 1 upon s square into 1 minus e raised to minus s upon 1 plus e raised to minus s, and last is 1 upon s into 10 hyperbolic s divided by 2. So what is the importance in this question? What we have given the Laplace transformation of this function 1 upon s square into 1 minus e raised to minus s whole square. So the first task is, what is this given function? Right, a function which is defined only on 0 to 2. So what is that function? Let us draw it. So the given function is this, and the Laplace transformation of this given function is 1 upon s square into 1 minus e raised to minus s whole square. So let us start with the definition of the Laplace transformation so that easily we can understand this quantity and that we will apply here. Suppose I have given any function f of t, then what is the Laplace transformation of f of t? The definition is integration over 0 to infinity e raised to minus st into f of t dt. I have given function f of t which is this, defined only on 0 to 2. After that the function is considered as 0. So I use that concept here. This is equal to integration over 0 to 2 e raised to minus st into the given function, and then plus 2 to infinity e raised to minus st, and what is the value of function here? It is 0, right? And so the Laplace transformation of f of t is equal to integration over 0 to 2 e raised to minus st into f of t dt. But I have given that the Laplace transformation of this function f of t is 1 upon s square into 1 minus e raised to minus s whole square. So that I substitute here, and therefore integration over 0 to 2 e raised to minus st into f of t dt, which is equal to 1 upon s square into 1 minus e raised to minus s whole square. So this is the information we have from the first line of this exercise. Now what I want to find the Laplace transformation of this periodic function. So the first question is, do you know what is the Laplace transformation of the periodic function of period p? So the Laplace transformation of the function f of t which is of period p is equal to integration over 0 to p e raised to minus st into f of t dt. And once this is periodic function of period p, this is nothing but 1 upon 1 minus e raised to minus p into s. This is not difficult to derive, that for any periodic function p, the Laplace transformation of f of t is 1 upon 1 minus e raised to minus ps integration over 0 to p e raised to minus st f of t dt. We have given the periodic function of period 2. See, this portion defined on 2 length interval, the same portion is repeated from 2 to 4, the same portion is going to repeat it from 4 to 6. So this is the periodic function of period 2. So if I substitute the value of p equal to 2 here, then this will become 1 upon 1 minus e raised to p equal to 2. So minus 2 as integration over 0 to 2 e raised to minus st f of t dt. Now say, what is this? 0 to 2 e raised to minus st f of t dt. What is 0 to 2 e raised to minus st dt? Is 1 upon s square into 1 minus e raised to minus s whole square, which I substitute here. So ultimately what do I have? Equal to 1 upon 1 minus e raised to minus 2s into 1 upon s square into 1 minus e raised to minus s whole square, which can be represented by 1 upon s square into 1 minus e raised to minus s whole square. Now if you look at this quantity 1 minus e raised to minus 2s, then it can be represented by this 1 minus e raised to minus s whole square. So this one is 1 square minus e raised to minus s whole square. So this is s square minus b square is equal to a minus b, a plus b. 1 minus e raised to minus 2s can be represented by 1 minus e raised to minus s into 1 plus e raised to minus n. And so this quantity equal to 1 upon s square into 1 minus e raised to minus s whole square divided by 1 minus e raised to minus s 1 plus e raised to minus s. And so these two quantity will be cancelled out. And so finally the remaining quantity is 1 upon s square into 1 minus e raised to minus s upon 1 plus e raised to minus s. And hence our answer is C. Now see, 1 minus e raised to minus s upon 1 plus e raised to minus s has this representation also, tan hyperbolic s divided by 2. But here with tan hyperbolic s by 2 we have 1 upon s. So if I want to represent this quantity in terms of tan hyperbolic, then this can be represented by 1 upon s square into tan hyperbolic s divided by 2. So this is the difference between option C and option D. And so finally the correct answer is option C, which you can modify by 1 upon s square into tan hyperbolic s divided by 2. Once this is the example related to unit step function and the graphical representation of the function, let me mention something more. See, here I have given 3 different curves. My base curve is this. F of t is equal to sin t defined on 0 to 2 pi. Now what I am doing, I am shifting this curve to the distance pi. So I have this thing. So see, whole curve is the same as it is, right? But now starting from pi. So now how do I represent this function in terms of sin t? So this can be represented by unit step function, because in the unit step function what do we know? The initial portion is considered as 0 and then otherwise we have the defined function. So here the initial portion from 0 to pi is 0 and my function is starting from pi. So this curve is represented by f of t minus pi into u of t minus pi. What does it mean? From 0 to pi the function has value 0 and after pi the function has this definition, right? Now in this situation what is happening? My function is actually this. This is my function. This is not the part of my function. That means my function is starting from 1. So from 0 to 1 I have nothing. Then from 1 the same function. So what is the difference between these two? Here I am shifting this function from up to unit pi, and whether I am cutting the initial portion of this function, right? So my function the same curve, but I am considering from the unit length 1, and this is my curve. So now how do I represent the portion of this function in terms of unit step function, which is f of t into u of t minus 1. So see, this is the difference, the shifting. So here the variable is t minus pi. There is no shifting here, so there is no change in t, but the initial portion is 0, right? So I am writing u of t minus 1. You need to understand these three differences. What is f of t? What do you mean by f of t minus pi into u of t minus pi, and f of t into u of t minus a in general, whenever we are working with the Laplace transformation of unit step function. I hope you like this concept.